Hello, grade 10 students, and welcome back. Today we will cover lesson 5.3 Forces in Two Dimensions, part 5. We will also work through the corresponding applications and homework questions. So let's get started. Okay, balance versus unbalanced. If the net force is 0, F net is equal to 0, then the forces acting on the object are balanced forces. Okay, in order to understand that, we can understand it in different levels. For example, we can say that whenever left equal to the right, this is balanced forces, or the forces here are balanced along the horizontal. And up equal down, which means they are balanced, the forces are balanced along the vertical. If this is the case, then the F net is equal to 0. And on the other hand, we can say that if we have balanced forces, then the F net is equal to 0 in the matrix notation. And we know that the F net can be calculated using the matrix notation as F1 plus F2 plus F3, etc. So actually, we have two different methods to be used whenever we have balanced forces. We can evaluate left and right, up and down, or even we can evaluate the matrix notation of the corresponding force or forces. Okay. Now, if the net force is non-zero, does not equal to 0, the forces acting on the object are unbalanced forces, which means at least left does not equal to right, so they are not balanced or unbalanced along the horizontal, or up does not equal to down, which means the forces are unbalanced along the vertical. In other words, in the matrix notation, we will find that the F net cannot be 0, so at least one of the components of both of them exists or are exists. And we know in the matrix notation, we write the F net as F horizontal, two inputs, F horizontal and F vertical. Now, for example, now here in this example, left does not equal to right, as we can see here that F2 is equal to 1 multiplied by 3, which is equal to 3 Newton. And on the right-hand side, according to the scales, we have two boxes, so this is equal to 6 Newton, and we know that 3 does not equal to 6, which means the forces are not balanced horizontally. Now, in example 4, here we have two forces acting on the object. For the F spring, we have 1, 2, 3, 4. So 4 multiplied by the scale, which is 5. As a result, the magnitude of this force is 20 Newton. And for the F gravity, the second force, which is acting here in this case perpendicularly downward, it consists of 3 boxes multiplied by 3. This is 15 Newton. And as we can notice here, 20 does not equal to 15, which means up does not equal to the down. And the case here is unbalanced forces. Now, if, for example, 5, we have already the magnitude of each force, and we can see here that F2 is equal to F1 since both forces has the same magnitude, which means left equal to the right, and the case here is balanced forces case. Now, in this example, we cannot evaluate unless we decompose F2 because this is angular force. And we know how to draw the component of F2 by complete the rectangular shape. This is the FH and this one considered to be FV. Now, let's evaluate the situation here according to the components. We can see here that down is equal up because up is consists of two squares, down is consists of another 2 squared. So up equal down here in this case. However, for the left and right, we have horizontal force to the left, but there is no any right hand force. So right does not equal to left, which means horizontally we have unbalanced forces. Now, for example 4, again, we need to decompose the two forces. So let's decompose them. This is F2V, and here we have F2H. For F3, we have F3H and F3V. So as we can see here, we have two forces acting horizontally, one to the left and the other to the right. So we can say left equal to the right since both of them have a magnitude of 2 units. Vertically, the situation is not similar to the horizontal one because we have two forces acting upward with a total magnitude of 4, 2 for each, and there is no any downward force. This is why we are dealing here with unbalanced forces since up does not equal to down. Now let's solve application 1. For each force diagram, determine whether the forces acting on the object are balanced or unbalanced. Now we don't know if the system here is under balanced or unbalanced forces. We need to evaluate the situation. As we can see here in question A or part A, we have two forces acting to the right, 2 and 3. If we add them together, we will get 5 Newton to the right, and on the other hand side, we have only one force acting to the left with the magnitude of 3 Newton, which means right does not equal to left. So they are unbalanced forces along the horizontal. Now, for this situation, we can see here that up and down are equal, left and right are equal, then left equal to right, up equal to down, and in both axes we have balanced forces. Now, for part C, in order to determine whether it's balanced or whether the forces are balanced or unbalanced forces, we need to evaluate each axis independently. So let's take a look to the horizontal forces. Here we have left equal right, since on the left hand side we have 60, on the right hand side we have 60. So left equal right. As a result, we have balanced forces along the horizontal. What about the vertical? We have 60 up, and for the downward forces, we have two forces here. The summation of these two forces is 60 Newton. So we have 60 up and 60 down, which means up equal down. And that is, as a result, all the axes has balanced forces, and the forces here in general are balanced. Next, here in this particular situation, we have an angled force. So F2 here is not along the vertical or horizontal. However, the component of this force is along the horizontal and the vertical. And we know that we have two components here. So let me draw the first component, which is F2V, and the second component, which is F2H, to complete the rectangular shape. Now, before we start evaluating, we need to find the magnitude of F2V and the magnitude of F2H. And then we compare each of these components with the corresponding force on that is along the same axis. So for F2, it can be decomposed into F2V and F2H. Now, since this angle here, it's between the vector, the force, and the vertical axis, then the angle here is the vertical angle, and the cosine should be applied for the vertical component, which means F2V is equal F2 cosine the angle. Now, for the horizontal component, we know that the direction of this horizontal component is to the left, which means we need to apply, so left, which means we need to add the minus sign. And since we have applied the cosine for the FTV, now we can apply the sine for the FTH. Now for F2, we have 80. The angle is 60. And 80 sine 60. Now let me add the minus. For that, the answers are 40 Newton along the vertical and 40 minus 40 radical 3 Newton along the horizontal. Now we can actually complete the solution using one of the following methods. So I will solve this question using the usual method, method 1. In method 1, we just compare between the left and right, whether they are equal or not. And as a result, we can tell whether the forces are balanced or are unbalanced. Now, in the method 2, we're going to use the matrix notation in order to solve the problem. So now let me remind you that the forces acting on the object are the F1, the F2H, which is the component of the F2, the F3, and the component, the vertical component of the F2. So first we need to evaluate left and right. Now F3 is equal to 40 and F2V it's equal to 40. So up equal down. So balance along the vertical. Now what about the horizontal? Now here in this particular case, we need to evaluate only the magnitude. Whenever we use this method, we just consider the magnitude, so no need to take in consideration the sign. Now the magnitude on the right-hand side here is 40 radical 3. What about the left-hand side? We found it to be minus 40 radical 3. However, here we need to take only the magnitude. So also here the magnitude is 40 radical 3, which means right equal left, and as a result, the system is under balanced forces. Now in method 2, we need to evaluate the forces but using the vector or the matrix notation. So we're going to find the resultant F net. We're going to find out what will be the resultant F net equal to, or the magnitude of it, or the component of this. And if we found that the matrix notation is, the F net in the matrix notation is 0, 0, then the F net is equal to 0, and the case is balanced forces. If the F net is not equal to 0, then the case here is unbalanced forces. So let's evaluate the F net now. So first, I'm going to write F net is equal F1 plus F2 plus F3. So let me construct the matrix notation of each one of these forces. Let's start with F1. For F1, as we can see here, F1 is along the horizontal. There is no any vertical component for F1. So we can say that the vertical component of F1 is equal to 0. and we have only the horizontal component, which is 40 radical 3, plus, now for F2, we know that we have two components, and we found out the magnitude of each one of them with the direction. So let me write here that the horizontal one is this one, and it's given by minus 40 radical 3. And for the vertical one is 40, plus for F3, this is F3, we can see here that F3 is perfectly aligned with the vertical, which means there is no any horizontal component for F3. So we can say that the horizontal component of F3 is equal to 0, and we have only vertical component, which is equal minus 40. And why it's minus? Because it's acting downwards, so it's pointed downwards. Now let's find out the summation here. We're gonna add up or find the summation of the horizontal first and then the vertical together. So horizontally, 40 radical 3 minus 40 radical 3 is 0, plus 0, it's equal to 0. So this is the horizontal component of the FNet. Now what about the vertical component of the FNet? If we found it also 0, then the whole system is under balance forces. Now 0 plus 40 minus 40, which is equal also 0. So the Fnet is equal 0, which means the system is under balance forces. So balance forces along the horizontal and balance forces along the vertical. Let me remind you here that you can choose one of the two methods to solve the problem, and no need to use both methods to solve it. Now, in this question also, we need to evaluate whether the system is under balance forces or not. And before we start, we need to decompose F1. Now, the angle here is vertical, or let's say with respect to the y-axis, and whenever the angle is with respect to the y-axis or the vertical axis, then we apply the cosine on the component that is related to this axis. And the component that is related to this axis is the y component of F1, and we apply the sign for the x component of F1. So let me write here that F1 can be decomposed into F1 y, which is equal minus, because it's acting in the negative direction according to the labels. This direction is the positive, and that direction is the negative. And by the way, this way of representation is called the cross representation. The previous one, it's similar to the plus. This is why it's called or known as the plus representation. Now let me complete. As we said, since the positive sense is upward, then the negative sense will be downward. This is why I need to add the minus sign here. So F1 cosine the angle, which is equal minus. We know that F1 is given by 50 multiplied by cosine 30, and the answer is minus 25 radical 3 Newton. This is the first component, which is the vertical component of the force F1. Now, what about the horizontal component? Now, again, here, the direction of F1x is opposite to the positive sense. The positive sense is pointed in this way. So we must add the minus sign F1 sine 30, which is equal minus 50 sine 30, which is equal to minus 25 Newton. And this is the horizontal component f of 1x. Again, I'm going to solve the same problem in different two methods. In the first method, we're going to use the evaluation of left and right. Let me write here for you that we found that f1x is equal minus 25. And for the f1y, we have minus 25 radical 3. So as we can see here, horizontally, we have balance forces, but this is not the case vertically. So let me write down here that horizontally, or let's say along x-axis, it's better to say x-axis. This is not horizontal. This is the x-axis along x-axis. They are balanced because the magnitude are the same. But along y-axis, they are unbalanced. So it can happen that the object to be subjected to balance forces along one of the axes and not subjected, or let's say subjected to unbalanced forces on other axes. Now for method two, this is method two. Remember that you will use one of these methods to solve the problem. In method two, I will use the matrix notation to solve the problem, knowing that if we have balanced forces, then the F net must be equal to the matrix 0. Now let's evaluate the F net. We don't know yet if it's balanced or not. We're gonna evaluate it. We know that the F net is equal F1 plus F2 plus F3. Now, for F1, we're gonna write the matrix notation for F1. The input must be the F1x and F1y. F1x we found it to be minus 25. F1y is equal to minus 25 radical 3. Plus for F2, the force F2 is perfectly aligned with the vertical axis, or let's say the y-axis here. It's not vertical anymore, it's y-axis, which means there is no any x component for this force. So the x component is 0, and we have only the y component of this force. Now what about F3? F3 here in this case is aligned with the x-axis, which means there is no any y component for this force. We have only x component. So let me write here that it's 25 and 0 because there is no any vertical component of this force. So let's add the things together to find the F net. And it's obvious that the F net is 0 along the vertical, but it's not 0 along the horizontal, or let's say along the y-axis. So minus 25 radical 3 plus 25, and the F net here, it's minus 18.3 Newton, which means unbalanced forces. And to be more specific, it's unbalanced along the vertical and balanced along the horizontal. Now let's start with the homework part. In question 1, they want me to find the value of P, knowing that all the cases are under balanced forces. So the forces here are balanced, which means balance along the horizontal and the vertical. And we can use the right equal left, the up equal down. Now here in this case, in the first case, it's obvious that we're going to use the information from the text, the balance forces, in order to find P. Now P is along the vertical, which means we're going to use up equal down. Up we have P, down we have 10, and that's it. We now have information about the magnitude of P, of the value of P. So now let's start with part B. In part B, also we're going to use this information, balance forces, which means left equal right, up equal down. Now what do we have on the left-hand side? We have 30 Newton. So let me write here that right equal left. So on the right-hand side, we have P. On the left-hand side, we have 30. And that's it. We know the identity of P, which is equal 30. For part C, Again, we're gonna use right equal left because we are dealing here with balanced forces. On the right-hand side, we have P and 2P, which is equal to the left. The left here is only one force and it's equal to 50 Newton. Now, this equation is the equation with unknown. We're gonna use the isolation method to solve this question. So let's divide both sides now over 3, and we will get the magnitude of this force. And the magnitude of this force, or the P, is 16.6. Remember that here we have a 3P. 2P for the first force and 1P for the second force, but the value of P itself is equal to 16.6. Now, in this question again, we are dealing here with balanced forces. Let me remind you that balanced forces means left equal right, up equal down, and this can be described using the matrix notation as F net is equal 0, 0. So we can use this approach to solve this problem or even that approach. I'm going to use both of them independently. And it's up to you to choose the suitable one. Method 1, I will use the left equal right, up equal down method. However, before I start solving, let me pay your attention that in both cases we need to decompose F1 and F2 because they are angled forces. As you can see here, F1 is not along the vertical nor the horizontal, it's angled with an angle 60 degree as well as for F2. So whether you want to choose the first method or the second method, in both cases, you should first break down or you should decompose F1 and F2. So let me decompose them for you. F1, first let me make a small sketch for the resultant decomposition. So for F1, we have F1V and F1H, as well as for F2, we have F2V, F2H, and P. So for F1, we have F1V. Now the angle here is with respect to the vertical or the y-axis. So the cosine should be applied along the vertical component or within the vertical component. F1V is equal F1 cosine the angle, which is equal F1 here in this case is 12 cosine 60. And the answer is, let me correct this for you. 60 Newton. Now for F1H, we have, as we can see here, F1H is to the left, so we must add the minus sign. Sine 60, which is equal minus 12 sine 60, and it's equal to minus 6 radical 3 Newton. This is F1. What about F2? F2 can be written as F2V and F2H. Due to the symmetry, and because we have the same angle, I know it's different direction, but same angle with the same magnitude, I should expect to have the same answers again. So no need to do the calculation or perform the calculation twice. However, here you should pay attention to the direction F1V because F1V is up, F2H to the right, which means both are positive. So I'm going to use the same values again, but with positive signs. Now let's start with the method. Method 1. Remember that our target is to find P. Now P is along the vertical. So in order to find P, I need to evaluate the vertical components together. And we know that we have balanced forces along the vertical because the whole system is under balanced forces. So we must have up equal down. Now, along the vertical, we have two upward forces, F1V and F2V, added together. They must be equal to P. So in order to find the value of P, I should evaluate this side. So P is equal. According to the result here, after the decomposition, we found that F1V is equal 6 and F2V is equal 6. So let me write here that 6 equals 6. And the value of P is equal to 12 Newton. Now I will use method 2 to prove that the final answer will be 12 Newton. Let me show you how. Remember, in both methods, I should decompose the angled force into two components. So I will maintain this part here, and let's go through method 2. In method 2, we know that the forces are balanced. This is the information that is between our hands, which means if net is equal to zero matrix, as I told you at the beginning, we can use the left, right, up, down approach or the matrix notation approach. In the matrix notation approach, we should keep in mind that in balanced forces, in this case, the F net will be equal to zero. So let me write that the equation should be written as F1 plus F2. And let me call P equal F3. Now for F1, we have two inputs, the vertical and the horizontal one. So always we start with the horizontal, and the horizontal component is for F1 is minus 6 radical 3. And for the vertical is 6. Plus the same thing can be said for the F2. However, for F2, we have positive or plus 6 radical 3 and plus 6 radical or 6 Newton. So 6 radical 3 and 6 plus for F3. Now here, F3 is aligned with the vertical and the direction of this force is downward. There is no any horizontal component for this force. So the horizontal is 0 and the vertical is minus the magnitude of it, it's P. Now we know that the F net is equal 0, 0. So let me write here 0, 0. And let me rewrite the equation again. Now, it's obvious that the first line is valid because if we add them up, we will get 0. Let me add them up for you. Minus 6 radical 3 plus 6 radical 3 plus 0, it's equal to 0. And this is true because we are dealing here with balanced forces. Now, what about the second line? The second line also should be add up to 0. However, we have here one unknown. By constructing the equation for this relationship among the forces, we will be able to find the P. So let me write here that 0 is equal, and I evaluate only the second line, the vertical one, 6 plus 6 minus P. Now let me move the minus P to the other hand side, it becomes plus. P is equal 6 plus 6 is 12 Newton, and I get the same result again using this approach. Okay, in question 2, the forces exerted on an object at a particular instant are represented in the diagram. The magnitude of each force is drawn to scale. Student claims that the net force of the forces on the object is equal to 0. So the student is arguing that the system here or the object here is under balanced forces. In other words, he's trying to say that up equal down, left equal right, or the F net is equal 0. Whenever I try to solve MCQ, I would always choose the easiest path. And in this case, I will choose the up and down, left and right method. Do you think the student claim valid? Why or why not? We have a certain uh, choices here. The first two are accepted the argument or the claim of the student, and the last two are denying this argumentation. So let's evaluate whether we are under balance forces or not, or the net forces are equal to zero. Now, whenever we have angled force, we need to decompose into two components. Let me decompose it for you. So we have here the decomposition, the horizontal one and the vertical one of this force. Let me call it F, and this is Fx, and this is Fv. Now, if it's true that the net force is equal zero, then directly we can say that up equal down and left equal right. It's obvious that left equal to the right because on the left hand side we have two boxes for the force, on the right hand side we have two boxes. Now let's evaluate the upward forces. Along the vertical we have only one force and it's acting with a magnitude of 2 units. And for the downward forces, we have actually two forces, two arrows. The first arrow is only one box, and the second arrow is two. So if we add them up together, we'll get to three. So three down, two up, which means they are not equal. So the vertical component of the magnitude along the vertical for each force or for the net force is not zero. This is why the correct answer here is not A or B, because here they are accepting the claim. Only C and D, one of them is true. And since we are talking about evaluating the components, then the statement that include the components is the true statement. So C is correct because no, because the vertical components of the forces do not completely add to zero, and this is true. Now, again, in this question, we need to evaluate the magnitude this time of the net force. So we need to find the F net. Now we have two angled forces. Let me decompose them by completing the rectangle. So let's call it F1, and this is F2, and this is F3. So F1, we have F1H, F1V, and here again, we have F2H and F2V. So vertically, they add up to zero because up equal down. Now horizontally, the scale is 1 Newton. So we have 1, 2 to the left and 4 to the right. Why it's 4? Because we have 2 units to the right for F2H and 2 units to the right for F3. So in total, we have 2 and 2, 4. Now, 2 to the left, 4 to the right. Let me add them together using the corresponding direction. So to the left means minus, and 2 has the minus. Plus, because to the right it's 4, and the answer is 2 Newton. This is why B is correct. Okay, for the question 4, an object is subjected by three forces as shown in the adjacent diagram. The forces are balanced. Calculate the magnitude of the force F. So here in this system, we have three forces. Two of them are equal but in magnitude, and they have different directions. They want me to use the information of the balance forces in order to evaluate the magnitude of this force. Remember, this force is equal to that force, but in different directions. Now, whenever again we have angled forces, we should decompose them into two components. So we have FV, and we have another FH here and FV. Now, again, we can use one of the methods that I have explained them earlier to solve this type of problems. However, I will choose the easiest one now, and I recommend you to try to solve it using the matrix notation. Now, for the method one, remember that we always start in both methods, we always start with decomposing the forces. So let me decompose the force F on the left-hand side, or even on the right-hand side. Let me start with the right-hand side. So we have F H and FV. Now the type of the angle here is horizontal angle, which means we need to apply the cosine along the horizontal. And since the directions for the FH and FV for this force both are positive, so we're gonna use the plus sign. So F cosine theta, F sine theta. F cosine is unknown, the F is unknown. However, the cosine is given by 60, so let me write here F cosine 60, and also here F sine 60. Do I need to add more details for this operation? No need at all, because the F is unknown, and they want me to find it. Try to decompose your force. No need to add more contribution in the solution because you will end up with one unknown. Now, the same thing should be applied for the left-hand force. However, here, due to the symmetry, no need to do the work twice because we have the same angle, as I said, we have the same force, same magnitude, so we're gonna get the same magnitude of each component, but with different direction for the one of the components. So let me write here for FH, we have minus F cosine 60, and for FV is equal plus F sine 60. Now, as we can see horizontally, I cannot do anything regarding left and right because the unknown will remain the same, and I can do nothing with that. Let me try to use the up and down because in the vertical axis we have very important information here, the F3, and we can use it to solve the problem. Now we know that we have balance forces, which means up equal down. Now in the upward forces, we have two forces, two vertical forces, and the statement of these, or the expression of these forces is given by F sine 60. So let me write F sine 60 for the first force and F sine 60 for the second force. And both are equal to 800 because we are dealing here with balance forces. Now we know that if we have a term similar to another term and we want to add them together, we just write them as 2f sine 60. So because if you have x plus x, if you have a term with identical another term and you want to add them up, you will get 2x. This is actually what I did. We have f sine 60 and another f sine 60. This is why I should write them as 2 of f sine 60 equal to 800. Now this equation is equation with unknown. By isolation f, by isolating f, we can find the value of it. So let me move everything else to the other hand side by dividing 800 over 2 sine 60. And the answer is 461.8 Newton. Now you should expect to have the same magnitude that I got via, or let's say if you use the matrix notation method. Now for the last question, in the last question, I will try to solve it using the matrix notation, and I would ask you to do or to try to perform the first method, the left, right, up and down method. So let me show you how to do that. Now here, the fnet is given by this value. So we know what is the fnet. Remember that the fnet is the summation of all forces acting on the object. So it's just F1 plus F2, and let me call this F3. Now the fnet is given by 2 radical 3, 2. Now for F1, F1 is along the horizontal, which means if you want to write F1 in matrix notation, you wouldn't find vertical component for F1. We have only horizontal component. However, here we don't know what is the value of F1 along the horizontal, so let me write it here as F1 to be unknown. Now for F2, the F2 can be decomposed into two components, the first component, the second component. Now for the horizontal component, it can be written as minus F2 cosine 30. And why did I do that? Because the angle here is horizontal angle. This is horizontal angle, and the direction is to the left. So we should apply the cosine along the horizontal. And don't forget to add the minus sign because it's pointing to the left. Now for the vertical component, we have 2v, which is equal F2. Now again, this is minus F2 because it's acting downward. Since we applied the cosine here, we can apply the sine now here, sine 30. So let me write that. For F2, we have horizontally F2 cosine 30 and minus F2 sine 30 in the matrix notation. Now, last force is the F3. Now, the F3 is acting along the vertical. There is no any horizontal component, which means we're going to write it as 0. And since it's acting upward, we're going to write 12 for the vertical component. Let's add or replace F1, F2, F3 with the corresponding matrix notations. F1 0 plus minus F2 cosine 30 minus F2 sine 30 plus 0, 12. Now you should be wise in choosing the suitable line to solve the problem. As we can see here, along the horizontal, we can find two unknowns. These unknown are F1 and F2. So avoid to choose first line to solve the problem. Instead of that, you can choose the second line because along the vertical, we have only one unknown here, which is the F2. So horizontally, or let's say vertically, we know that 2 is equal 0 minus F2 sine 30 plus 12. Now this equation is an equation with one unknown. Let's solve it to find out what is the value of F2. Now I would move F2 to the other hand side with the sine 30 and the 2 to the right hand side by changing the sign and changing the sign here. So let me write that F2 sine 30 is equal to 12 minus 2. Now we know that F2 it's equal to, let me move sine 30 downward to the denominator. So 12 minus 2 over sine 30 or 10, because 12 minus 2 is 10 over sine 30. Now, as a result, we will get the value of F2 to be 20. So it's going to be 20 Newton. Now we have the value of F2. We can use it back in the forces along the horizontal to evaluate F1. So let me make my space now. You know that F2 now is equal to 20 Newton. So let me record that F2, we found it to be 20 Newton. I will use it again here when I construct the horizontal forces or relationship F1 minus F2 cosine 30. Now I'm considering the horizontal components, knowing that F2 is given by 20. So let me replace it with 20. Now this equation is the equation with one unknown. The unknown is F1. Let me move everything else to the other hand side by changing the sign from minus to plus. So 2 radical of 3 plus 20 cosine 30 equal to F1, which means F1 is equal. Let's evaluate this using the calculator, and we will get that the answer is 12 radical of 3. And as an additional exercise for you, try to evaluate left and right, up and down after I found the magnitude of each force. I want you to try to find what will be the F net. Let's assume that the F net is not given. What will be the F net along the horizontal components and along the vertical components, according to the result that I got. You should expect to get 2 radical 3 according to the assumption, and 2 as a resultant for the summation of all forces along the horizontal and the summation of all forces along the vertical. Remember, this is just an extra work. You can do it to evaluate your work or to double check your work. However, let me remind you that after we found the answer for F1 and F2, no need to do or perform any additional step. And also you can use the first method that I have explained it to you earlier in order to solve the same problem. That's it for today. I hope you have found this video beneficial for you. And thank you for watching, and good night.